So thank you very much for staying on to the last talk. My name is Karl Larsson. I work at Aligned, and we here at Aligned, we do a design control management software. And part of that software is, of course, managing the risk assessments when it comes to medical devices. And risk assessment is something that is very central to our industry. And I'm sure that many of you that listen here today have performed risk assessments with various success. And I remember when I did my first risk assessment, it's more than 20 years ago, working at a medical device company, and they said, well, you take this template, and I mean, you know the device, and then you just fill out the template and come up with all the risks. And I tried to do that, and I was feeling very overwhelmed by the time. There were so many unknowns in there. I had a really hard time finding the right wording, finding the right granularity, knowing how to define the different parts, what goes where, etc. How can I know these things about probability of an error for a device that doesn't yet exist, these kind of things. So I guess we've all been there in the dark, but with experience, you get better and better on this. And we sell aligned elements to many different customers. We have more than 200 medical device customers, and they all implement risk assessments in aligned elements, performing their risk assessments there. And they all come to me with the same kind of story. They say, Karl, we just use 14971. We just do what 14971 tells you to do. Nothing fancy, nothing special. That's what we do. And lo and behold, they all do this differently. So there's many different takes on risk assessments. And what I'm going to talk about here today, if I can get this moving, is I'm sure that you're well aware of this process of risk management or risk assessment being divided into several subsequent segments, starting out with risk identification, finding out what kind of potential risks are there, then evaluating them, how bad are they, and then, of course, going into the control of those risks. And today, we're not going to talk about the second two ones. We're going to focus on the risk identification, because what I want to talk about today is different methods for performing risk identification. And I'm going to suggest a structured approach and one that is also multi-tiered. And why do I do this? Well, it can be kind of illustrated here with a Swiss cheese, using the Swiss cheese idea that if we provide several different angles of looking at something and provide several different barriers or identification methods to find risks, we will probably find more of them and will then be able to build a much safer device. And I'm sure that you have been in situations where you talk to other people in a risk assessment session and you really realize that these other people have a completely different perspective than you have on the device, and that they can identify completely different risks. So when it comes to this risk identification, what is the outcome of the risk identification process? And in general terms, it's just risks, right? But I want to define it a little bit tighter. And in this example that I'm going to show you today, the outcome of the risk identification are hazardous situations. And I'm sure that many of you know this from ISO 49071, a hazardous situation being when a potential hazard and a human coincide in time and space. So a hazard might be that there is fire, and that's fine as long as there is no human close to that fire. But as soon as a human in time and space coincide with that hazard, we got ourselves a hazardous situation. Not necessarily a concrete harm, but that's how we can look at hazardous situations. And I'm soon going to dive straight into these different methods that we're going to look at for risk identification. But I can tell you that there are in general two different methods that we're going to apply. So all these different methods that we look at, they fall in one of two camps. And one is the art of decompositioning, which means that we take something really, really large, and in order to identify risks that are coincides with this large thing. We need to decompose the big thing into smaller parts and look at those smaller parts individually in order to get a better grip on the risks to identify. It's a little bit like the saying, how do you eat an elephant? Well, one bite at a time. The other type of method is more of an enumeration type, meaning that we start out with some kind of defined list. And then we just go through this list and ask ourselves, to what extent is an item in this list applicable to my device? And that also has its benefits, and I'm going to talk about that in just a little bit. So the idea of today's exercise is to take a look at 5 different risk identification methods and compare them a little bit and see what their superpowers are. And in the end, we want all these risk identification methods to yield hazardous situations. And then we can work with these hazardous situations, evaluating them and mitigating them later on. And I'm going to talk about something that Dr. Jani talked about in our previous talk here, namely the usability task analysis as a risk identification process. And this has become really a favorite of mine. I have a separate show on this that you can find on our YouTube channel, where I go through details of how to perform a task analysis and how you can use our product aligned elements to conduct that and document that. And the cool thing with the usability task analysis is, on one hand, that you can perform it fairly early in the process. You don't need to have a final design of your device in order to perform this. So you don't need to know all the materials that go in there, the exact shape, the exact display, where the buttons are. You can just focus on how you intend to interact with the device, right? So it's a lot about how are we going to use the device. And in the context of analyzing how we use the device, we can then look for potential use errors. So that's the basic type of errors or risks that we're going to get out here. They are induced by the user, either that the user understands something incorrectly, or there is a foreseeable misuse, or there is a plain error. And what could this look like then? Well, we start out with defining what we call use scenarios. And here I have made an effort to divide them into different sections, so we can, without really knowing too much about a device, we can say that it will go through a number of user-related stages, meaning contexts where the user will interact with the device. For example, the user will probably perform some kind of unboxing, some kind of installation. Maybe there are setup and calibration, there are normal runs, there are maintenance, there is service, there are maybe decommissioning. And we know that there's going to be an interaction between a user of some sort and the device when we do this. So these are candidates for our use scenarios. And then if we dive into the internal of use scenarios, we then perform something that we call a task analysis. We start by writing down things like, what's the goal of the use scenario? Sorry about that. What kind of user group are we looking at? And the slide that Dr. Janis showed was a lot more elaborate than this, including the use environment, etc. And also meditating on, is this a candidate for a summative evaluation? But the essence, the core of a task analysis is basically describing how the user interacts with the device in some kind of steps. And here I have a very rudimentary task analysis, just writing down the tasks, like connecting the device to the power outlet, connecting to the network using a LAN cable, maybe removing some transportation locks. This is during the installation of the device. And the idea is then that when we have now decomposed the use of the device to an individual task, we can then think about, are there any risks associated with this particular task? And I'm, of course, very glad that Dr. Jani looked at the exact same kind of risks that I thought about, like connecting a power cable or some kind of cable to the device. So the user here that performed this task analysis have identified the tasks and have also started identifying some risks related to those tasks. And once those risks are related, we can then go on, of course, and evaluate them. So we have the hazardous situation here that we've already entered. And of course, then start working on the severity and probability or whatever parameters we have, calculating a risk, then adding control measures. And what we get then in the end is, of course, this kind of traceability, starting with the use scenario, going into subtasks, and then the tasks then tracing to different risks. And these risks are then evaluated and mitigated, as you can then imagine, going to the right in this kind of grid. So we use now the use scenario as a risk identification technique, writing down what kind of tasks we have, and then think about what kind of risks can entail from this particular task. And the upside, of course, of using this type of risk identification is we do two things in one. I mean, we need to do the use scenarios, we need to do the task analysis based on IEC 62366. And now we also leverage this task analysis in our risk management process. And of course, we can then, depending on how we can see how these use scenarios then connect down the line to some kind of a risk or some kind of severity, we can then make an educated estimation on which of these use scenarios that goes into the summative evaluation, because we can draw automatically, or letting the system draw upon the related final risks or severities associated with the particular use scenario. So given that we have just worked down this flow for free, we get, is this use scenario a correct summative candidate for the evaluation? So that's why I really like this. I mean, you do one kind of workshop with this, and you get so much out of it. So that's one way. This is one of these decomposition methods for generating risks, and I can highly recommend it. Now, the second one is a bit more mundane. It's the first risk identification method that I learned when I was 26, 27. And I was handed a list of generic hazards. So there was a long list that mentioned things like explosion, mechanical force, ionizing radiation. And these were then extracted from someone from ISO 4971 that says maybe you should consider these generic hazards. And I tried to go down in history to see where does this come from. And I found that there is an old military standard in the United States for preliminary hazard analysis that does exactly this. It contains a list of generic hazards, and it tells the user to go through the list of the generic hazards and ask themselves the question, okay, is this particular hazard applicable to my device? Can this hazard happen in my device? Yes or no? And then if yes, okay, what kind of hazardous situation may then arise given this hazard? And this makes it possible to evaluate a wide range of different possible hazards that you might not have thought about yourself, because you might not associate it with your device. So if we look at this, how this could be applied to inaligned elements, we have prepared libraries with this that contains roughly 75 different generic hazard categories. And the idea is that you then go through each of these and ask yourself, is this applicable to my device? Yes or no? Some will be, there will be probably whole sections that are not applicable. So if your device do not produce any acoustic energy, you can say, no, these are not applicable, and qualify why. And in some cases, you will say that they are applicable. And the system then expects you to elicitate what kind of hazardous situation then arise from this particular hazard. And of course, the system can then automatically detect whether you have actually traced hazardous situations from a given generic hazard, and otherwise signalize if that's not the case, so you don't miss out on that. So what does this look like? It looks like this. So I have this magnetic field generic hazard, and then I tell the system, yes, it is applicable. And the system then expects me to start writing down what kind of hazardous situations are we talking about then when it comes to magnetic fields. And otherwise, the system will tell me, you need to work on this. This is not consistent with what you've promised. And one of the upsides with using a hazard category list is, in my view, that it's a great way to document not only the risks that you have identified, but it also documents what you have considered and excluded, right? So you can show an auditor, look, I thought about acoustic energy risks. We thought about them, and we concluded that we don't have any because we don't have any acoustic energy in our system. We considered radiation energy. We did it, and we thought hard about it, and we realized it's not applicable to us. So you don't only show the risk that you'd have identified, like the positive thing, but also the negative thing, maybe what you have considered and explicitly excluded because it's not applicable to your device. And in my experience, auditors like this. They like that you can show that we have cast a very wide net and take a very structured approach to this, and we've thought about a lot of things, and we have even excluded and write down why we exclude them in order to prove that we have thought very wide. And now, so hazard categories then is an example of the second section. It's not a decompositioning, it's more like an enumeration. Like, so we go through a given list. Of course, you can expand on this list if you find new types of hazards that are not applicably written here. But it's not a decomposition, it's more about an enumeration. So that was 2. Now, maybe the most common risk identification method I see in my experience is this that stems from the FMEA. And here the idea is that let's take given design of a device. So we know what the device looks like, we know its parts, we know what the parts are made of, we know how the parts are connected. Basically, we have a thing, right? So we have a thing, and we can now decompose this thing into smaller parts. And then we can ask ourselves, what happens if this thing breaks or fails? And this can now be contrasted with, for example, the use scenario or the usability task analysis that we did previously, which is more about what happens if the user messes something up, which is a completely different take on risk, on identifying risks. Because here we focus on how can things break, how can things fail, and we're really, really talking about parts here. But it does follow a similar thought, being a decompositioning process, taking the entire device, dividing it up in smaller parts, and consider these parts. And therefore, it works similar in aligned elements than when you would document. You would document your components, maybe. This is just one way of structuring the decomposition of a device. So I have components on one hand, and it's divided up into parts. And for each of these parts, then I consider what could then possibly fail. And based on these things of what could fail, I can then identify hazardous situations. And I will then end up with a new kind of traceability where I break down a component into parts and then look at the failures and then look at the hazardous situation. And the astute listener would now identify that, hey, did we have this hazard in a previous example? And this is then something that is very important here. If we use a combination of different risk identification methods, we should expect that there is a certain overlap between these different methods, and that even though we use these different methods, they would come to the same conclusion that there are a set of risks. So we will find risks that we have already identified with one method to reappear in different methods, because there is going to be a certain overlap, and that is not bad. That just means that we have done our job very well. And of course, the interesting thing is that for each additional risk identification method that we add, we're going to probably find some new risks, but we're also going to see that we have already identified many of the risks that come out of that additional risk identification techniques. So that was the third one. That was like a component decompositioning. And now I'm going to look at something called HAZOP. You might have seen this one in 4971. That's one of the very many risk identification methods that get mentioned. I personally don't have a lot of experience with this one. It comes from the oil and gas industry or process industry, where you have, big plants that which are process industries. So it could be a paper mill, it could be an offshore platform, and the common thing here is that we have energy and material that goes through a process, right? So there is a flow of energy and or different materials that go through this plant. It comes in one end and something happens and something comes out at the other end. So these in this industry, there's a lot of valves and pipes and pumps and heat exchangers and vessels, etc. And this industry has then come up with their own way of identifying risks, because they clearly notice that we can't brainstorm risks, what kind of risks there are on an offshore platform. It's just too big. We need to divide this down and look at what they call then individual nodes. And nodes is just a very generic name for a thing. And a thing here could be a valve or a pump or a heat exchanger or whatnot. And then the real cool thing about HAZOP is that they use this thing called guide words. I think this is the main takeaway, what makes HAZOP special, that they use a set of so-called guide words that should then trigger your mind into come up with new ideas on what possible risks are. So the combination of nodes and what they call guide words, and a third thing called parameter, which is again a very, very generic name for just a thing, and then use permutations or combinations of guide words and parameters, like a guide word and a parameter. For example, the guide word no and the parameter flow will yield no flow. And then you ask yourself, okay, what would happen if we didn't have any flow here? What if there's no cooling water going into the reactor? Well, then we end up with Chernobyl, basically. But that's like the way that they use guide words to identify risks. And it's very systematic, and I like it very much. And what would this look like in a system like aligned elements? Well, you would then identify your HAZOP nodes. And when I did this, I realized that this looks very familiar to the process that I see a lot in IVD products. Because IVD products is or some of them at least, is very much process-like, that you run a diagnostic test, you start with a blood sample, then that blood sample gets processed somehow. The output of that process is then maybe it's incubated or filtrated or magnetized or washed or read or mixed or diluted or whatnot. And then you can use these individual steps as your HAZOP nodes and look at, okay, what I took one example here of automated packaging cartridge in an incubator. So we have an incubator, and in that incubator, we want to put a cartridge, and in the cartridge, there are blood samples, right? So the cartridge with the blood samples goes into the incubator. What could possibly go wrong here? Well, I wrote down the parameter cartridge placement, and I then went through the guide words. Okay, and here we have a guide word that says reverse. Okay, what would happen then if we put the cartridge in the reverse order into the incubator? We put it in backwards, basically. What kind of risk would entail from that? Is that a risk? Or we use cartridge placement. What happens if it's too soon, for example? What if we place the cartridge into the incubator before it has reached its target temperature? Or what if we place several cartridges in one incubator slot? What would happen then? Is that a possibility? Is that a risk that we should consider? So just using these guide words triggers ideas about potential deviations that couldn't happen. So that's the superpower of HAZOPs, using these guide words. And if you have an IVD device, maybe this is something that you should consider then, and at least take a look at it and see if it yields risks that you haven't thought about so far. Right, moving into another type of lists. All right, so if you got a copy of 40971 and it's not the newest one, you know that in Annex C, 40971 tries to help you by telling you you ask yourself questions. And this is listed in Annex C of the 2012 edition. I think it moved to the 24971 in later editions. But you can see here on the right, this is an example of what these questions look like. Is energy delivered to or extracted from the patient? You should consider this. You know what kind of energy it is, etc. So we kind of 40971 has this list of questions. I think it's 30 plus questions. And some companies use this in their risk identification process. And the upside of this list here is that it looks very heterogeneous. So there's many different aspects, not following a very straight line. But the relevant thing here is that it does consider things that are very relevant to medical devices, like energy, like substances, like user involvement, etc. So it's very tailored for identifying risks in medical devices. And again, just like the hazard category list, I think it's great to go through these kind of questions and see if there are any risks that can be identified from them. And there will be questions that are simply not applicable to your device. But again, it's great to include those and say that I have considered them, but I have excluded them or discarded them because they are not applicable. So you can show people that we thought about this, but it's not applicable. We will move on to the ones that are applicable and extract hazardous situations from those. And in a system like Aligned Elements, you can find then predefined libraries, which has all these, which has information that are very similar to these questions. And again, you have information about the question, and you can then say, is this applicable or is it not? And if it is applicable, you can then list your hazardous situations here, and then continuing later on with the evaluation. So another great way, and I think a very common way to do risk identification, is to use these questions. They do have their merit, I think. Now, the final method that I would like to mention, it maybe sound very simple, almost banal. And this is about just going through your design input and your user need and just look at those user need and design input requirements and ask yourself, what kind of risks might this particular design input entail? So the input for the risk identification here is your existing user needs and design inputs. That's what you're going to use as input, and just consider those. Yeah, what kind of hazardous situations might arise given a particular requirement or user need? Yeah, and the upside here is that you have a tremendous fit to your device, right? You're really gonna only think about things that are very, very applicable to your device here. We saw in the other methods that there is a risk of performing a lot of risk identification work or putting in a lot of work on things that are not necessarily applicable, that maybe doesn't have a very good fit to your particular device. Here, the fit is super tight, right? So because you will really, really consider the risks that are coming from your individual user needs that are unique to your device. And this is, of course, a dynamic approach. So each time you add a requirement or add a user need, you need to consider that one for risks, because that would then be in your process. And again, if you change a risk, or if you a requirement, or if you change a user need, you need to reconsider your risk assessment, which is exactly what you should do. You know, this is exactly what you should do. Changes made to the design should be considered from a risk perspective. This, of course, also depends on the quality that you have of your user needs and your design inputs. But it's also a method that I find valuable, that could definitely provide value, and where you could then unearth risks that are not, that you couldn't do with the other more generic methods. I'm gonna stop here talking about risk identification methods. There are plenty more. We haven't talked a lot about software. We haven't talked a lot about cybersecurity. We haven't talked at all about process risk assessments. There is a good ISC standard which comes with software hazard identification in one of the annexes. So if you have software and you don't know where to start, that's a good place to look at. Then, of course, there is these things that you already know. You should look at your internal data, being experience from previous products, looking at service reports, complaints, non-conformities. We can extract a lot of known risks from that you can implement in your new versions of your device. And of course, look at external data. You could look in the FDA mod database. You can look at the implant files, which is a place on the internet that collects information about implants. Or if you're living in Switzerland, we have this database called the SFSN to look for devices that are very similar to your own, and you will find out were there any callbacks or recalls on these devices? Why were there recalls? What kind of error did they have? Is that an error that I can have in my device, and should I then cover for that? Then there is the more exotic, since we are now closing into Halloween, we have a method called the nightmare headline method. I've never used it, but I think it's an awesome method. The idea here is that you think about what is the worst kind of news headlines that could ever be associated with our device, right? So, infants die because of faulty device in the ICU, etc. So, and then you take that headline and you ask yourself, okay, how could we end up here? What would be the hazards or the hazardous situation that would place us in this imaginary nightmare headline situation? And there are, of course, a number of methods that I haven't mentioned here. Like, we can start out with the obvious one, which is brainstorming, which is with 20 years of experience in risk assessment, I would say if you hear brainstorming, then shy away, right? Because brainstorming is not a structured approach. And it's no way to prove afterward what you have thought about and what you haven't thought about. So if somebody says we should sit down and brainstorm about risks, then you should fire them, right? Because they don't know what they're doing. There are, of course, other risk methods like fault tree analysis, the 5 whys, and the Ishikawa, but they are more about finding the root cause of a risk and not necessarily identifying risks in the first place. So that's why I haven't mentioned them here. So again, I just want to reiterate that these kind of methods come in different groups. Like, we have some that are more static, like these kind of lists that we go through and say, is it applicable or not? Or we have these more dynamic ones that are about decompositioning, having a big thing, we take it into smaller parts, and then we analyze the parts. And they both have their advantages and disadvantages. But now your reaction might be, but Karl, if I start applying this, I'm going to have so much more risk management work. I want less risk management work, Karl. I don't want more work. How can we bring it down? And you're quite right. There's going to be more work. The more risk identification methods you apply, the more work you're going to have. But I don't think that for each risk identification method you add, you won't necessarily add with a linear amount of additional risks, because we're going to reuse the already identified risks in the different methods. So we might have hazardous situation that comes from our HAZOP analysis that we then later see that, well, that's exactly the same ones that comes up from our use scenario analysis. And if we have written them down once, we can just point to these existing risks. So we can do the work here and show what we have looked at, and then just point at these already established risks that we have identified in other methods, and then leverage these already identified risks. Now, if you ask me, like, Karl, what's your top 3 recommendation? Like, of all these, what would you use? Well, I would definitely use the usability task analysis if your device has anything to do with users, and most of them do. And again, the reason for that is that you get so much more out of it than just identified risks. You get those use scenarios, you get great input for those summative evaluations, you get automatically a great way to categorize whether a particular use scenario is a candidate for summative evaluation. So that's the first one. And moreover, you tend to get really good usability when you use usability task analysis, because you're going to improve on your usability, and customers love that. They just love it. The second one, hazard category list, is very simple to understand. It's very simple to explain. Again, it casts this wide net. There's going to be categories that are not applicable, but that thing of going through things that aren't applicable, it will also give you a sense of confidence, right? And confidence comes from, to a certain extent, from being able to show what you've looked at and also what you've not looked at. So using the hazard category list, you can show that I've used a structured approach. I've considered all this, some of it's applicable, and where it's applicable, I've done my work. So that's one that is very easy to use. And I mean, if you do hardware, it would be a crime not to do a component analysis, or what some people just call an FMEA. Basically ask yourself, okay, given the thing that I have here in my hand, what happens if the different parts break or fails? Yeah, so that would be my top 3 recommendations. But you know your device best. You know in your experience what kind of risks that you maybe failed to identify when you get this information from your post-market. So you might need what bring the best value to you. So again, just summing up, why do we want to use a structured risk identification approach? Well, it's to remove uncertainty, of course. It's to uncover important risks that might not be possible to do if you just use one method. And finally, to increase the confidence that you have in your own risk assessment. So I hope that you can apply 1 or 2 of these ideas from today. And if you have any questions, please let me know. I'm available here in the chat for another minute.